this video I'm going to be making it specifically for the M105 classes at IUK. These are topics that are coming out of section 7-4. We're going to be taking a look at how to go about dividing radical expressions. Alright, we've got a couple different quotient rules here. They are assuming that b is not 0 because we can't divide by 0, but across the board, alright, if I've got one great big radical and I've got a quotient underneath it, sometimes it is to our advantage to break it up into two individual radicals, one on the top, one on the bottom, so that we can work with each of them individually. On the other hand, sometimes I am given a problem where I start with a radical on the top and a radical on the bottom, and it helps to rewrite it as one big radical so that we can work with this expression algebraically underneath. So two different rules here that we're going to kind of touch on in the same video. Alright, so this one we're going to start out with this first one here. We'll have a great big radical, alright, with an expression underneath. Okay, now, as it sits right now, I cannot do any type of simplifying with this radical. Alright, so it's going to help me to split it up into two individual radicals. So I'm going to have the square root of an x squared on top. I'm going to have the square root of a 25y to the 6th on the bottom. Alright, now hopefully then you can see now real easily, oh, I can take the square root of x squared. That's just going to give me an x. Alright, and both of these turn out to be perfect squares as well. I can take the square root of the 25, which is going to give me a 5. The square root of y to the 6th is going to be a y to the 3rd. Okay, keeping in mind how we can easily get that using a little bit of division here. 6 divided by that 2 is going to give me a 3rd if you are not comfortable with the square root of y to the 6th being a y to the 3rd. Okay, so that being able to split it up into a radical on the top and the radical on the bottom made that easy to work. Alright, now for this one, we've got the 4th root of a 7y to the 5th over an x to the 12th. Again, I take a look at this expression that's underneath, and I can't do anything with it. I can't simplify it algebraically. So it will be to my advantage to rewrite it as the 4th root of a 7y to the 5th on the top, and a 4th root of x to the 12th on the bottom. Alright, now this one on the bottom here, alright, this turns out to be a perfect 4th root. Alright, again, I can go 12 divided by 4, that's going to give me a 3. So I know that that bottom simplifies out to an x to the 3rd. Okay, now, this top on the other hand, let's take a look at it. 4th root is 7. Well, I can't take the 4th root of 7, so I know that that's just going to stay right the way it is. Alright, but I'm going to break up the 4th root of that y to the 5th. I cannot do 5 divided by 4, okay, but if I start going down, as I have demonstrated in my other videos, alright, start going down on those exponents. If I go down to a y to the 4th, 4 divides by 4, alright, so that's how I'm going to know how I want to break this up. So I'll have a 4th root of a y to the 4th. Alright, I've used 4 of those y's. I have one of those y's left over. So 4th root of a y to the 1st. I don't need to write the 1 there. Alright, now, what this one in the middle here, that's a perfect 4th root. 4 divided by 4 gives me a 1, so a plain y is going to come out there. I cannot simplify these, so they're going to stay underneath the root, and then I'll have the x to the 3rd in the bottom. So simplifying this out to a y, putting these two together, multiplying those like radicals there, I'll have like a 7y underneath. I should say like indice right there, not radical itself. And then an x to the 3rd. Okay, so this was just a couple of examples showing this first rule where you've got a radical and it's got a quotient underneath, and you can't really do anything algebraic to that quotient to begin with, so then you separate it so that you can work with it. Alright, a couple more examples using the second rule. Okay, on both of these, I'm starting out with two small radicals, something on the top, something on the bottom. Alright, and again, looking at this, it's not going to be to our advantage to start working with as it is. So if I rewrite it as one big radical, then it allows me to algebraically work with what's underneath it. So the first step would be to change it to a great big radical, putting that 16x to the 5th y squared on top, and then the 2xy to the negative 1 on the bottom. This allows me then to work with this algebraically and simplify it. Okay, 16 divided by 2 is just going to be an 8, so that's going to simplify really nice. I'm going to be able to use laws of exponents on these. All right, and again, different people do laws of exponents different. I kind of do them a little bit different than everyone else here, so let's see. All right, so I'm going to have the 8. All right, an x to the 5th over, an x to the 5th over an x to the first power. When dividing like radicals, we subtract the exponents. So that's going to give me an x to the 4th. All right, let's just go ahead and subtract exponents on the y's. When subtracting there, 2 minus a negative 1 is going to give me a 3. So I'll have a y to the 3rd. It's probably the easiest way to go about this. All right, now you do have to be careful. You cannot assume that after you do that you're done, because you need to take a look at this and see if you can simplify this radical farther. All right, the cube root of 8. I can actually do the cube root of 8. That's 2. So that means I am going to be able to keep simplifying here. So I'm going to break this up the way I do and look at each individual part. So I'm going to have the cube root of the 8. All right, then I'm going to have the cube root of the x to the 4th, and then I'm going to have the cube root of the y to the 3rd. All right, I separate all the variables, I separate the coefficient, and I look at each piece individually. Cube root of 8 there is going to be a 2. All right, now 4 does not divide by 3. Okay, so I'm going to take that exponent, I'm going to start decreasing until I find a number that does divide by 3. So I'm going to go from 4 to 3. 3 divides by 3, so that means that's going to be a perfect cube root. So I'm going to have the cube root of an x to the 3rd. I've used 3 of those x's, I have 1 left over. So I'll have the cube root of an x. All right, on this one, 3 divides by 3. This is a perfect cube root, so I can just go ahead and take the cube root of that. That's going to give me a y. All right, going ahead and showing all my steps here, we'll keep this 2. All right, 3 divided by 3. All right, is 1, so that's going to give me an x to the 1st because this is a perfect cube root. All right, I can't do anything with this. And of course the y just stays put. All right, so on this one, everything that has come out is going to be multiplied out in front. So 2xy, and then cube root of the x. All right, so last example here. We're going to take a look at, again, something that's got a radical on the top and a radical on the bottom. Notice that they're both 4th roots, so I can apply this rule. The first step I'm going to do is I'm going to rewrite it as one great big radical of a 243 x to the 23rd y to the 13th, and then over a 3 x to the 3rd y to the negative 6th. All right, by doing that, that allows me to then take this expression and work with it algebraically. All right, and on this one, you might need to grab a calculator on this, but if not, 243 does divide by 3, so that's going to be really nice. So I'm going to have the 4th root. All right, 243 divided by 3 is 81. Okay, you can check that on a calculator if you need to. Again, on the x's, I'm going to apply laws of exponents. When dividing like bases, I subtract those exponents. So 23 minus 3 is going to give me a 20. So I'm going to have an x to the 20th. All right, now doing the exact same thing on the y's. When dividing like bases, I subtract those exponents. So 13 minus a negative 6, that's going to be a plus plus. That's going to give me a 19, y to the 19th. Okay, now again, after you do that step and you've simplified to here, you can't stop. You've got to keep going and checking to make sure that you can, whether or not you can simplify more. So I break this up into the 4th root of the 81. I break it up into the 4th root of the x to the 20th, and I break it up into the 4th root of the y to the 19th. All right, looking at each individual piece by itself. 4th root of 81, hopefully at this point you've started working with this enough that you've started getting some of these lower perfect roots. That's going to be a 3. All right, 20 divided by 4. It does, that's 5. That means that this is going to be a perfect root, so this will be an x to the 5th. All right, 19 divided by 4 doesn't work. Okay, so I'm going to start going down. I'm going to decrease that exponent by 1 until I find a number that is divisible by 4. So if I go to 18, 18 divided by 4, nope. Go down to 17, 17 divided by 4, nope. Go down to 16, 16 divides by 4, yes it does. So that means that'll be a perfect 4th root. So 4th root of a y to the 16th. Okay, that's going to be the highest perfect 4th root for that y to the 19th. Okay, now I've used 16 of those. That means I have 3 left over. Y to the third. If I multiply this back out, multiplying like bases, I add the exponents, I get back to that y to the 19th. Okay, so this 3 is going to stay the same because I'm not going to do anything with it. The x to the 5th is going to stay the same. This one I can divide. 16 divided by 4 is 4, so that means it's a perfect 4th root of y to the 4th. And then I can't do anything with this 4th root of y to the 3rd. Okay, now obviously you want to leave your answer like this with all these dots in here. These 3 things can be multiplied together, so write them a little bit nicer here. 3 times x to the 5th, y to the 4th, times the 4th root of a y to the 3rd. Alright, so 4 examples there of dealing with those dividing radical expressions using those quotient rules, going back and forth. Definitely thanks for watching. If the videos are helping, don't forget to give me a thumbs up and subscribe to the channel. Thanks.